Okay, a football team has a 25% chance of winning when it snows. So 25% chance. And then a 40% chance if it doesn't snow. So 40% chance if it doesn't. And then a 60% chance. Suppose there is a 60% chance of snow. Totally different story. There's a whole bunch of data. You have to be very careful with every single wording. And we'll say it all in a second. What is the probability that they will lose? So all this, trying to get it together, what we're trying to say is as follows. We have two events. The first event is if it's going to snow. First of all, we're asking, is it going to snow? Yes or no? The second event is a game. And it's what's the results of the game? Do they win or do they lose? Do they win or do they lose? Depending on if it snows or not, then there's also a different thing of will they win or lose. Okay, from there, looking at our data, we got to figure out where do all these percents go. That's the hard part. Let's look at the last one. Suppose there is a 30% chance of snow. That's pretty, hopefully, straightforward. 60% chance of snow. I can't say that right. A 60% chance of snow simply, doesn't that 60 go right there? 60% chance of snow. Now use your brain and think about what is the chance of not snowing. You should realize with percents, right away, 40%. It's either going to snow or not. Okay, so we're done with the 60%. Next, the football team has a 25% chance of winning when it snows. Now, the moment I say when it snows, is that a condition? They have a 25% chance of winning when it snows. So the moment I say when it snows, it's saying if it snows, they have a 25% chance of winning. So when I say if it snows, we basically say, boom, we're up here. We're on this track. And so the 25% now says they have a 25% chance of winning. So that 25% goes right there. Because if it's snowing, they have a 25% chance of winning. What would the losing be? Don't these two have to add up to 100? So wouldn't this be 75%? Okay, the next one. But a 40% chance if it doesn't snow. So they have a 40% chance of winning, if you kind of read that, if it doesn't snow. So if it doesn't snow, they have a what percent chance of winning? A 40. Another conditional probability. A 40% chance of winning if it does not snow. Does not snow, 40% chance of winning. So what would that be of losing down here? 60. Okay. The next question is, what is the probability that they will lose? So, that's basically just asking, how many different ways could they lose? They could lose if it snows, and they can lose if it does not snow, correct? So don't we have to find both those? Because either it's going to snow and lose, or it's going to not snow and lose. So we've got to find out both those and add them. How do we find these values right here? This is an and statement. The end results are and. So we want snowing and losing. Snowing and losing, what you technically just do is it's an and statement. So you're going to multiply the two. When I do that, when I multiply the two, I end up with, in this situation, I did it earlier, so it's a little bit easier. You get 45%. If you multiply the two and simplify it, you get 45%. So So that is 45%. For this one, not snowing and losing, that would be 40% times 60%. That would be 24%. So what's the probability of them straight losing? Add those up. My answer, oops, this was supposed to be 24%. You just add those up. So 45 plus 24, you have a 69% chance of losing. Not very good odds for this team. Not a very good team. All right. Next problem. It's a lot simpler. For the next problem, probability of getting a face card given it's a diamond. So with the moment we say given it's a diamond, we throw everything out but diamonds. How many diamonds in a deck?
13.
There are 13 diamonds in a deck. How many of those diamonds are face cards?
3.
3. King, Jack, Queen. We're done. That's it. With conditional statements, with givens, you first focus on the given. That's the bottom. The top is how many that out of the given that are left. And we're done.